Hello students, today's first question is, in triangle XYZ, what is the length of YZ? So, there is a triangle XYZ, we need to find the side YZ. Now, moving to statement 1. Statement 1 tells me the length of XY is 3. So, XY is equal to 3. So with this I can't find the value of YZ, so we will say that statement A is not sufficient to answer my question. Now, moving to statement 2. Statement 2 tells me the length of XZ is 5. So XZ is 5. So this also doesn't give us any information about YZ, so I will say that statement B is also not sufficient to answer my question. So this makes statement D also not sufficient. So now moving to statement C, that combining both the statements, I have xy equal to 3 and xz equal to 5. Now there is a very important theorem to understand over here, that the length of any side of a triangle is less than the sum of other two sides and greater than difference between the other two sides. Fine. So this means that yz is less than 8 and greater than 5 minus 3, 2. So from this I can just find the range of yz. But I can't find the exact value of yz. Yz can be equal to 3, can be equal to 3.5, can be equal to 4. So there are different values for yz. So I will say that statement A, that both the statements are not sufficient to answer my question, is the right option. If the average arithmetic mean of n consecutive odd integers is 10, what is the least of the integers? So we have been given, let us suppose x is the first odd integer, x plus 2, x plus 4, so on, x plus 2, n minus 1. So this is the nth consecutive odd integer. If you put the value of n equal to 1, so this becomes 0 and the first integer will be x. If you put the value of n equal to 2, then 2 minus 1 is 1, so x plus 2 will be the second consecutive odd integer, right? Now we have been given that the sum of all these divided by n is equal to 10. We need to find the least of these, which is x, right? So within this information, we'll move to statement 1. Statement 1 tells me the range of the n integers is 14. So what does that mean? That means the greatest and the least, their difference is 14. So x plus 2, n minus 1 minus x is equal to 14. So x and x gets cancelled. So I will left with 2n minus 2 equal to 14. This applies to n is equal to 16 and n is equal to 8. Now since n is equal to 8, so I can write 8 terms which add up to 8x plus 56. Divided by, so this is 8x plus 56 divided by 8 should be equal to 10, as we have been given that their average is 10. So 8x plus 56 will become equal to 80, and from here I can calculate the value of x equal to 3. So least of the integers is 3. So I will say that statement A is sufficient to answer my question. Right? Now moving to statement 2. Statement 2 tells me the greatest of the n integers is 17. So that means x plus 2 n minus 1, the greatest is, we are supposed it to be x plus 2 n minus 1. So this is equal to 17. Now here we will talk about some examples. Let us suppose we have 2, 4, 6, 8, 10. These are 5 consecutive even numbers and their average will be the sum of these numbers. 2 plus 4 is 6, 6 plus 6, 12, 12 plus 8, 20 plus 10, 30. So 30 divided by 5 is equal to 6. Now whenever there is a evenly distributed data means that the difference between the numbers is equal or they are forming an AP. So basically they are forming an arithmetic progression that the difference is equal. So we can also find the arithmetic mean by adding the least and the greatest number and dividing it by 2. So least over here is 2 plus 10 divided by 2 is 6. So you see that the average is coming out to be same. We will assume some other example, 5, 7, 9, 11. So these are basically consecutive odd integers. So their sum is 7 plus 5, 12 plus 9, 21 plus 11, 32 by 4 will be 8. So 8 is the average. Now if we add 5 plus 11, this is 16 divided by 2. So average will come out to be same. Right? So with this information, we'll move to this question. We have assumed that least integer to be x. We have been given that the greatest of the integer is 17. So x plus 17 divided by 10 divided by 2, should be equal to 10. Or x plus 17 should be equal to 20. From here I can get the value of x equal to 3. So we can say that statement B alone is also sufficient to answer the question. So for this particular question we will say that statement D, that both the statements alone are sufficient to answer the question. If x, y and z are positive numbers, so this has been given that is if x, y and z are positive numbers, is x greater than y greater than z? So this is the question. X, y, z are positive integers that has been given to us. We need to find whether x is greater than y greater than z. Now moving to statement 1. Statement 1 tells me that xz is greater than yz. So since these are all positive numbers, if I divide both sides by z, as z is common in both the inequalities, so I will get x is greater than y. But I don't have any information about z. So without the knowledge of z, I can't tell you about x is greater than y is greater than z. So I will say that statement A is not sufficient to answer my question. Now moving to statement 2. Statement 2 tells me that yx is greater than yz. Now y is common over here, dividing both sides by y. I get x is greater than z. But still I don't have any information about y. So I will say that statement B is also not sufficient to answer my question. So this means statement D is also not sufficient. Now moving to statement C, which means combining statement 1 and 2. So now statement 1 tells me x greater than y. Statement 2 tells me that x is greater than z. So that means basically x is greater than y, z. So now we will assume some scenarios. Let us suppose x is having value 6, y is having 4. So 6 is greater than 4. And since x is greater than z also, so let us suppose x to be 6 and z to be 3. So in this case I can say x is greater than y is greater than yes. But if I suppose x to be 9 and y to be 6, so x is greater than y. And if I suppose x to be 9 and z to be 8, so again x is greater than z. But in comparison of y and z, y is less than z. So we'll say no. Why? So for this question, since we are getting by combining the statements yes, may or may not be condition, so I will say that statement E, that both the statements are not sufficient to answer the question that x is greater than y is greater than z. E is the right option. If x square plus y square is equal to 29, what is the value of x minus y whole square? So we have been given that x square plus y square is equal to 29. We need to find the value of x minus y whole square. So this is basically a minus b whole square, which is equal to a square plus b square minus 2ab. Right? So this will be equal to x square plus y square minus 2xy. Since x square plus y square is equal to 29, I will write 29 minus 2xy. We need to find the value of this. Or we need to find the value of xy. Right? So with this information, we will move to statement 1. Now statement 1 gives me the value of xy equal to 10. So this is what I need to solve this. So 29 minus 20, 2 into xy. So 2 into 10, 20. So x minus y whole square is equal to 9. So I will say statement A is sufficient to answer my question. Now moving to statement 2. Statement 2 tells me that x is equal to 5. Now since x is equal to 5 doesn't solve my problem that I need to find the value of y, or I must be given the difference x minus y. So I will say that statement B is not sufficient to answer my question. So for this particular question, statement 1 alone is sufficient to give me the value of x minus y whole square. After winning 50% of the first 20 games, 50% of first 20 games means 10 games it played. Team A won all of the remaining games it played. What was the total number of games that Team A won? So we have been given that out of first 20 games, team won 10 games, right? 50% of 20 is 10. After that, it played certain number of games and it won all of the remaining games. So let us suppose that remaining games be x. Let x be the remaining games, remaining number of games. So total number of games that team A played will be 20 plus x. And since all the remaining games which the team A played, team A won those games, so total number of games that team A won will be 10 plus x. So we need to find what was the total number of games that team A won. So basically we need to find 10 plus x, right? Or I can say that we need to find the value of x, right? Now with this information, moving to statement 1. Statement 1 tells me team A played 25 games altogether, right? So what does that mean? That means 20 plus x should be equal to 25. This gives me the value of x to be 5. And total number of games the team won will be 10 plus x, 10 plus 5, 15. So I can say statement A is sufficient to answer my question. Now moving to statement 2. Statement 2 tells me that team A won 60% of all the games it played. So what does that mean? This means basically 60% of 20 plus x, which is further equal to 60% is 3 by 5. So 3 by 5 of 20 plus 3 by 5 of x. So this gets cancelled. So I will be getting 12 plus 3 by 5 of x, right? So since this is also the 10 plus x is the number of games it won. So equating 12 plus 3 by 5 of x equal to 10 plus x. From here, shifting 10 to right hand side and 3 by 5x to this side. So I will be getting the value of x equal to 5. So I can say that statement B is also sufficient to answer my question. Since both the statements are individually sufficient to answer the question, I would mark the option D, that both the statements are sufficient to answer my question. Right? For this particular question, statement D will be the right answer. Is x between 0 and 1? So we need to find whether x is between 0 and 1. Nothing has been given else about this, whether it is an integer or non-integer. So with this information, moving to statement 1. X square is less than x. So generally we see that x square is always greater than x. So here it has been given that x square is less than x. So we will consider some scenarios for this. I've written some values for x. Let us suppose it to be minus 1.2, minus 2, minus 0.2, plus 0.3, plus 1.2 and plus 3, right? Now calculating their square, so minus 1 by 2 square is 1.44, and you see this is negative and x square is positive, so I can say x square is greater than x. So this is not a case. Now if I consider x to be minus 2, x square becomes 4, so x square is greater than x. If I consider it to be between 0 and minus 1, let us suppose the value to be minus 0.02. So the square becomes 0.04. Since this is negative, this is positive, so I can say x square is greater than x. But if I consider some values between 0 to 1, so let us consider 0.3. So here its square becomes 0.09. In this case, x square is less than x, right? Now 1.2 square is 1.44. Again, x square is greater than x, and for 3 it is 9. So x square is greater than x. But for this particular case, when x is between 0 and 1, x square is less than x. So we can definitely say that x is between 0 and 1 only then, since we have carried out all the possibilities, integer as well as non-integer, ranging from negative to between 0 to minus 1, to 0 to 1, to beyond 1 to infinity. So only x square is less than x in case of when the number is x is between 0 and 1. So we can definitely say that statement A is sufficient to answer my question. Right? Now moving to statement 2. Statement 2 tells me that x cube is positive. Now if x cube is positive, that means x is positive. If we take x to be negative, now let us suppose minus 2 cube, so that will be minus 8 and x cube will be negative. So this doesn't tell me any information about whether x is between 0 and 1 or not. So for me, statement B is not sufficient to answer the question, and the right option for this question will be statement A alone is sufficient to answer the question, that yes, x lies between 0 and 1 just because x square is less than x, and we have seen the examples where x square is less than x only when x is between x and 1. If m and n are non-zero integers, so basically we have been given that m and n is not equal to 0 and these are integers. Is m raised to power n an integer? So we have to find whether m raised to power n is an integer or not. Now with this information, moving to statement 1. Statement 1 tells me that n raised to power m is positive, right? But we need to find whether m raised to power n is an integer or not, right? So let us suppose some values for this. Let us suppose, since these are integers and not equal to 0, let us suppose m is equal to 2 and n is equal to 2. So n raised to power m, 2 raised to power 2 is 4, which is positive. So we are satisfying the statement 1. But if I calculate m raised to power n, this also becomes 4 and this is an integer, and I will say that statement 1 is sufficient. But if I assume m to be 2 and n equal to minus 2, so minus 2 raised to power 2 is equal to 4, which is positive. So again n raised to power m is positive. But if I calculate m raised to power n, so that is 2 raised to power minus 2, which is 1 by 2 raised to power 2, which is 1 by 4. And this is not an integer. No, for this. So I am getting may or may not be condition. So I will say that statement A is not sufficient to answer my question. Now, moving to statement 2. Statement 2 tells me that n raised to power m is an integer. Now, n raised to power m integer, so same we will consider these examples here, where if I consider m equal to 2, n equal to 2, I get both n raised to power m and m raised to power n as integers. But if I assume m to be 2 and n equal to minus 2, then n raised to power m becomes an integer, but m raised to power n is not an integer. So again I am getting may or may not be condition. So I will say statement B is not sufficient, which means statement D is also not sufficient. Now, combining statements 1 and 2, that n raised to power m is positive and n raised to power m is an integer, in both we have considered the same examples and we are getting may or may not be condition. So we will say that statement C is also not sufficient. So for this particular question, statement E, that both the statements are not sufficient to answer my question, is the correct option. What is the value of xy? So nothing else has been given. We just need to find the value of x multiplied by y. Now, moving to statement 1. X plus y is equal to 10. So we can have different values for x and y so as to add up to 10. Let us suppose x is 6 and y is 4. 6 plus 4 is 10, and then multiple x into y becomes 24. Now if I assume x to be 7 and y to be 3, their sum adds up to 10. But the product xy is 7 into 3, 21. So we are getting different values for xy. So we'll say that statement A is not sufficient to answer my question. Now, moving to statement 2. Statement 2 tells me that x minus y is equal to 6. Again, I can have different values for this. Let us suppose x to be 8, y to be 2. Then 8 minus 2 is 6. And the product is xy 16. If I assume x to be 10 and y to be 4, then 10 minus 4 is 6. But the product is 40. So we're getting different values for xy. So I will say that statement B is also not sufficient, which means statement D, that both the statements alone are sufficient, is also out of question. Now, moving to statement C, which means combining statement 1 and 2. Now, from statement 1 I get x plus y equal to 10 and x minus y is equal to 6. Now since these are two equations and we have two variables, we will simply mark option C, that it can answer the question xy. So you will simply take option C and move further. But for the sake of question, I will solve this problem. So adding, we will get y cancelled. So twice x equal to 16 and x equal to 8. But since x plus y is equal to 10, so I will get the value of y equal to 2 and the product equal to 16. So we are getting a single value of xy, which is 16. So I will say that statement C is sufficient to answer my question. If n is the least of three different integers, so there are three different integers. Let us suppose first has to be n, another xy. So these are different integers, and n is least of them. So what does that basically mean? And all are greater than 1. So n is greater than 1, greater than x is greater than n, and y is greater than x. So let us suppose these are the three integers. Now we need to find the value of n, right? Now, with this information, we will move to statement 1. Statement 1 tells me that the product of three integers is 90. So product of three integers is 90. So that means n into x into y is 90. Now here I will prime factorize it. So 2, so this becomes 90 equal to 2 into 3 into 3 into 5. Now we have to let the product in such a way that, let us suppose n is equal to 2, x is equal to 5, and y becomes 9, because we have to arrange in this order that n has to be least. So we get the value of n equal to 2, right? But if I suppose n to be 3, y to be, x to be 5, and y to be 6, again 6, 5, 30 into 3, the product is 90, but the n of the value of n comes out to be 3. So we can say that the statement A is not sufficient to answer my question. Now, moving to statement 2. One of the integers is twice one of the other two integers. So what does that basically mean? That one integer is twice the other. Now, we can have 6, 12, 13 where x is twice of n, or I can have 5, 6, 10 where 10 is twice the 5. So we are having different values for n equal to 6 or 5. So I will say statement B is also not sufficient, which means statement D is also not sufficient. Now looking for statement C. It says combining statement 1 and 2. Now, first statement tells me the product is 90, and second tells me that one number is twice the other. Now from these two examples, these are the only two possible 3 different values, right? Now we see that in the statement 2, in the example 2, we see that y is twice of n. So I will write all the factors of 90, right? So here 3, 5 and 6. So 6 is twice of this, so its product is 90 and the value of n is 3. Now let us suppose some other values. Let us suppose 5, 10. So 5 multiplied by 10 and the third letter let to be unknown should be equal to 90. From the here, if I calculate the value of this, so it comes out to be 90.50. So this is 9 by 5, but since they are integers, so this is not an integer, so we will say this is not the value for n. Now if I suppose 15 multiplied by 30, because I have to keep the numbers in such a way that one should be twice of others. So 15 multiplied by 30 multiplied by an unknown should be equal to 90. So 90 comes out to be, so unknown comes out to 90 divided by 30 by into 50. So this is 1 by 5, again a non-integer. So the only value that is possible for this, keeping both the statements, is when n is equal to 3, value of x is 5 and value of y is 6. So we are getting a single value of n which is 3. So we will say that statement C is sufficient to answer my question, that is by combining both the statements. Is x square greater than x? Right? Now, we have been asked simply question, is x square greater than x? We are not given anything about whether it is an integer or non-integer. So with this information, we will move to statement 1. Statement 1 tells me that x square is greater than 1. Right? Now, if x square is greater than 1, now let us suppose we have a negative value for this. Let us suppose that x is negative or x is positive, right? In both the scenarios, if x square is taken care, so both will become positive, right? So if x is greater than 1 or x is less than minus 1, so x square will be greater than x, right? We have been simply given that x square is greater than 1. So in both the cases, x square has to be greater than x. So we are getting this simple yes. So we'll say that statement A is sufficient to answer my question. Now, let us suppose some values for this. If x is equal to 2, then x square is 4, x square is 9. So x square is greater than x. If I assume x to be minus 2, then x square is 4. Again, x square is greater than x. So statement A is alone sufficient to answer my question. Now moving to statement 2. Statement 2 tells me that x is greater than minus 1. So x is greater than minus 1. If I draw it on number line, so x is greater than this value towards right. Now again, taking example x equal to 2, x square, so x square is greater than x. So yes, but here 0 is also there. If x is equal to 0, then x square is 0, but x square is greater than x. And between 0 and 1, we have calculated in the previous question also, if I assume some value between 0 to 1, so x is equal to 0.3, x square becomes 0.09, where x square is less than x. So we are getting no for this. So we can say we are getting yes, we are getting equal to, and we are getting no for this. So we will say that statement B is not sufficient to answer my question. So for this particular question, statement A alone is sufficient to answer my question. Michael arranged all his books in a bookcase with 10 books on each shelf and no books left over. So we have not been given how many shelves are there, but it has been given that Michael arranged the books in such a way that there were 10 books on each shelf and no books were left over. After Michael acquired 10 additional books, he arranged all his books in a new bookcase with 12 books on each shelf and no books left over. How many books did Michael have before he acquired the 10 additional books? So let us suppose he had X number of books before he acquired the books. Now since he arranged it in a 10 books on each shelf, so I can say that X has to be a multiple of 10. Because he arranged 10 books on each shelf. We don't know the number of shelves, but it has to be a multiple of 10. But as he acquired 10 more books, he was able to arrange those books in 12 books per shelf with no book left over. So that means X plus 10 has to be a multiple of 12. Now, we need to find the value of X, that what were his number of books before he acquired 10 additional books. So that is X. So with this information, we will move to statement 1. Statement 1 tells me that before Michael acquired the 10 additional books, he had fewer than 96 books. So what does that mean? That means X is less than 96. So since X has to be multiple of 10, so I have written down the values for this. So that will be 10, 20, 30, 40, 50, 60, 70, 80, 90. And X plus 10 has to be 20, 30, 40, 50, 60, 70, 80, 90, 100. Now X has to be multiple of 10 and we have written all the multiples of 10 below 96. And X plus 10 just by adding 10 to these values. Right? Now out of this, X plus 10 has to be multiple of 12. Out of these values from 20 to 100, only 60 is the number which is the multiple of 12. Right? So we can easily write that X plus 10 is equal to 60, and here from here we get the value of X equal to 50. So we are able to answer this question from statement 1. So we will say that statement A is alone sufficient to answer this question because we are getting a single value for X. Right? Now moving to statement 2. Statement 2 tells me that before Michael acquired the 10 additional books, he had more than 24 books. So this means that X has to be greater than 24. Again, since X is a multiple of 10, so I will write all the possible values 30, 40, 50. So there is up to 120, 130 and so on. So X plus 10 will be 40, 50, 60, 70, 80, 90 and so on. Now again, since X plus 10 has to be multiple of 12, so I'm getting value 60 which follows this, and 120 is also there, 180 will be also there. So I am getting different values, X equal to 50, X equal to 110. So since they are different values for X, so I will say that statement B is not sufficient to answer my question. And for this particular question, statement A is sufficient to answer the question. Right? If xy is greater than 0, does x minus 1 multiplied by y minus 1 equal to 1? Right? So we have been simply given xy is greater than 0. Now, x minus 1, y minus 1, solving this I get xy minus x minus y plus 1 equal to 0. Or if I shift 1 to this side, I get xy minus x minus y equal to 0, or xy is equal to x plus y. So any of this is comes out the result, so we can say that x minus 1 multiplied by y minus 1 equal to 1. Now with this information, moving to statement 1. Statement 1 tells me that x plus y is equal to xy. So this is what we have calculated. If this is true, then this is also true. So we can say that statement A is sufficient to answer my question. Now moving to statement 2. Statement 2 tells me that x is equal to y. Right? So let us suppose some value for x equal to y equal to 2. So in that case, 2 minus 1, because x minus 1, y minus 1 has to be equal to 1. So here 1 into 1, so this is equal to RHS. So we say yes. But if I suppose x equal to y equal to 3, right? We just have to follow this, that xy is greater than 0. So x into y is equal to 9, which is greater than 0. In this case also, x into y is equal to 4, which is greater than 0. But here, 3 minus 1 is 2, 3 minus 1 is 2, so it comes out to 4, which is not equal to 1. So we can say no. So statement B is not sufficient to answer this question. So I will say for this particular question, statement 1 alone is sufficient to answer the question. Right? So Thank you for today's lecture. Bye bye. Take care.